All right, this is a video on functions, on analyzing functions and their graphs. So we're going to fill in some notes here at the top. It says we can analyze parts of a function by describing them as blank or blank. So let's go ahead and fill those in. We can describe them as increasing, or the opposite, decreasing. We can also describe them as linear, or the opposite, nonlinear. So we're going to use these describing words to talk about the graphs that are listed down below here. So if we look at this one, it says describe the parts of the function shown below. So we're looking between x being 0, which would be right here, and x being 4, which is right here. So I'm going to go up to the line. So we're talking about this portion of the line. So just between these two places, what is going on? Are we increasing or decreasing? We are obviously increasing. And if you remember, linear just means that it forms a straight line. So, did this form an exact straight line or is it starting to curve? Well, if you notice, it's starting to go back down. So it's going to be nonlinear. So we're going to say increasing and nonlinear. All right, let's look between 4 and 8. So I'm going to change up my color here. So we're going to go between here down to 8. So again, we're looking at just this portion of the graph. What do we notice is happening here? Well, we can clearly see that we are decreasing. And again, you're looking to see it is decreasing, but is it decreasing in a straight line or is it nonlinear? Because of this little loop here at the end where it's starting to go back up, we're going to say that this is nonlinear. All right, let's go ahead and move this up a little bit. So now we're going to talk about distance versus time graphs. A distance versus time graph shows us how far two objects are from one another. So consider what the following types of lines on a distance versus time graph would represent. So we're looking at graph A, B, and C, and we're going to describe them down below here. So if you're looking at A, you're going to notice that we are moving at a constant speed. The reason it's moving at a constant speed is because it is a straight line, so it has a increase of the same amount each time during the time, and the distance is moving up, so it's moving away. So it's moving away from the object. So we're going to say an object moving away at a constant speed. Let's look at B. Now, B, if you notice, it's coming down. It's coming down closer to time. So it started far away and now it's getting closer. So this one here is going to be an object moving closer. And because it is straight, we're going to say it's moving at a constant rate as well. So at a constant speed. You would know it's not a constant speed if you saw that the graph was not straight. The line was not straight. If it kind of started to curve or go up and down, that tells you that your speed was changing throughout the time. So C, if you notice, C is a flat line. So it's just no change really. So over time, the distance is not really going very far. So what we're going to say here is that an object is at rest. So an object at rest, which means it's not moving. It's stationary. And not changing its distance. Okay. Let's go ahead and look at D and E. Now, D and E, if you notice, are not straight. They curve. They have a bend in them. They're not a circle, but they are starting to like they would form a parabola of some degree. If we were to perhaps extend this graph in this direction, you could see that it could go up and then right back down. So what we're going to say here is that it's moving away because it's going away from zero. It's going away from the x-axis, so it's going away. But the speed is not constant, but it is increasing because it's going faster. So for this one here, I'm not going to write this down. I'll let you guys go ahead and write it down. What we're going to write is an object moving away and increasing speed. An object moving away and increasing speed. All right, for E, you notice that it's also moving away from the X. It's going out towards something, so it's also moving away. But if you notice the speed, it took off, it was increasing, but then it starts to level off. Now, it could eventually dip back down. We don't know. They didn't really extend the graph that far. But we can say that the speed is decreasing, it's slowing down. Because of this bend right here, obviously the speed is starting to level off. And that leveling off means that it must be slowing down. So for E, we're going to say an object moving away and decreasing speed. An object moving away and decreasing speed. All right, let's look at number 1. Number 1, we are going to match these graphs to the scenarios down below and see which one if you were to graph this unique scenario, would it look like? What would the graph look like? So A says Kaylee got off the bus at her house. The bus made 2, keep that in mind, more stops. Now, if it stops, that means the line kind of went flat all of a sudden. So you're looking for some flat parts. So she got on the bus. So she's going away. So we should be moving out from the distance. Okay, so we're getting more distance. 2 stops before she arrived at school. All right, well, if I look at this one here, I can see that there's only 1 stop. There's only 1 flat area of rest. So obviously that's not going to work. Now this one here does have 2 stops. It is moving away. Okay, let's come over here and look at this one. This one goes up. It has a very short stop, but then it drops down. It stops again, and then it takes off. So I would say the best graph for A is this middle one. So we're just going to put A right next to the graph. B, Brennan and his dad left for school in Dad's car. So again, they're moving away. They got stopped at the train tracks for several minutes before they were able to continue to school. So I'm looking for 1 stop. I'm looking for 1 area of rest, and it says here that they rested for several minutes, which means it should be a long rest. The only one up here that would make sense for that one is this very first one, B. So obviously this is where they caught the train. Now, by process of elimination, we can say that this last one is C, but we're still going to read it to make sure that we can make sense of the graph. Cameron left for school with his mom. All right, so left for school is this part right here. But remembered he left his English project at home. So mom stopped, turned around, and went back home. So if you notice, he went back to his destination where he originally started from. She took him home to get his project. So this is the area of rest where he had to go in, get the project. And then they headed back to school. So this is back to school. So that's how you would read this graph here. So we're going to put C. All right, I'm going to let you guys continue to finish up the rest of this side of the worksheet, which ends this video tutorial.